Hello folks, now we're on the 35s, which is known as the kissing moles sheet. We're going to fill in a couple of the fill-in-the-blank questions up at the top, and then we'll work some of the mathematical problems down below. Just like in the previous sheet, H2O is a molecule. H2O is made up of two atoms of hydrogen and one atom of oxygen. And number three, in 1 mole of H2O molecules or water molecules, there'd be 2 moles of hydrogen atoms and 1 mole of oxygen atoms. In this problem, I want you to realize that subscripts can be read as mole ratios. Mole ratios have an infinite number of sig figs. So going back to question 3 right here, in 1 mole of water molecules, there are 2, which is an infinite number of sig figs, moles of hydrogen atoms, and 1 mole of oxygen atoms. Again, infinite sig figs here, infinite sig figs here. Let me erase that, and we'll start the mathematical problems. It'd be very handy if you had your calculator. Pause the video every once in a while. Today we're going to be using the mole map that's down below. It's also on the cover of your unit pack. Today we're going to spend our time between this island and this island. The name of the bridge that's right here is 6.02 times 10 to the 23rd. What that means is anytime I go between this island and this island, I will be using the number 6.02 times 10 to the 23rd. So I'm going to erase that. I'm going to move us back up to the problem. And the first problem we have is how many moles are there in 3.01 times 10 to the 23rd atoms of sulfur? So I'm going to start with atoms, and we're going to go over 2 moles. Again, we've got to go across that bridge called 6.02 times 10 to the 23rd. So we start the problem with what they give us and the label. So 3.01 times 10 to the 23rd atoms of S. I put a multiplication sign, I put a division bar. Whatever is right here for a label, I put on the bottom of the next step. So I go atoms, sulfur. Okay? According to our map that's right down here, I'm right over here. I'm going across this bridge going this direction, and I can in fact go to moles. So I can put mole of sulfur on top. This bridge is called 6.02 times 10 to the 23rd. That means that is going to be involved. So you have to ask yourself, are there 6.02 times 10 to the 23rd atoms in 1 mole? Or is there 6.02 times 10 to the 23rd moles in 1 atom? Well, there's 6.02 times 10 to the 23rd atoms in 1 mole. In most of our problems, the mole number will be some small whole number that is used. Rarely is it anything else. If I did put this 6.02 times 10 to the 23rd on top, that would be saying that I have a mole, which is 6.02 times 10 to the 23rd moles. So the 6.02 times 10 to the 23rd will go with atoms, and the 1 will go with the mole. We crunch this number, and we end up getting 0.500 moles of sulfur. Let's check our sig figs. Here we have 3 sig figs. Here we have 3 sig figs. Up on top we have infinite sig figs, so our answer should have 3 sig figs. Let me erase all this, and I will start the next problem for you. If you need to pause it to write down some stuff, go ahead and write down some stuff. In problem number 5, we're starting with atoms. Actually, my mistake, we're starting with moles, so let me erase that. We're going to start with moles, and we are going to go over here to atoms, going across that bridge. Each bridge is a multiplication sign, so if you go across one bridge, you should have one multiplication sign in your problem. Number 5, how many nitrogen atoms are there in 2.0 moles of nitrogen gas, which is a diatomic element? That means nitrogen gas is N2. N2. So how many atoms are there in 2.0 moles of nitrogen gas? I start with what they give me. 2.0 moles of N2. I put a multiplication sign, I put a division bar. Whatever the label is here, I put on the bottom of this first step. So I go mole N2. So right now I am right here on Mole Island, and I am going to go across this bridge over to atoms and molecules. So I can go to atoms or molecule island, and in this case we are going to go with atoms. Okay. So in this problem, we have to go use 6.02 times 10 to the 23rd. Well, we go 1 mole, 6.02 times 10 to the 23rd, atoms of N2. Now that doesn't make any sense. So we're going to have to fix that a little bit, because N2 is not an atom. So let's erase a little bit. And let's change that atom into a molecule of N2. Well, if it wants it in atoms and we're in molecules of N2, that's not where we need to be, so we need to go one more step. So we go molecules, N2 down there, and we can go to atoms of N. So in every molecule of N2, there are 2 nitrogen atoms. I'm going to erase a little bit, clear things up a little bit. We crunch some numbers. This label cancels out with this label. This label cancels out with this label. We're left with our answer in atoms of nitrogen. We end up getting, for an answer, 2.408 times 10 to the 24th. Let's go check our sig figs. Here we have 2 sig figs. Here we have infinite sig figs. Here we have 3 sig figs. Here we have infinite sig figs. Here we have infinite sig figs. So if we look at all of that, we should end up having an answer with only 2 sig figs. So the answer would be 2.4 times 10 to the 24th atoms of nitrogen. The rest of this worksheet is homework for you. Stop in if you need some help.